Okay, so what we're going to do in this segment is we are going to convert from polar coordinates into rectangular coordinates. And then in the last segment, we're going to do the opposite. We're going to convert from rectangular coordinates into polar coordinates. Now, these are the two formulas that you need to convert between a rectangular coordinate and polar coordinates, okay? So basically, this formula right here is the conversion between r and theta and x. And then this one is the conversion between r and theta and y, okay? And so basically all you have to do to convert from polar coordinates is, if I give you a polar coordinate r comma theta, all you have to do is put the r here, put the theta here, and do r times cosine of whatever the theta is, and whatever number comes out, that's going to give you your x coordinate, okay? And then the same thing down here with y, you put the r in here, put the theta in here, and just do sine of theta, multiply it by r, and that just gives you the y coordinate. And so when you plug them into this formula and this formula, you then get an x and a y, and you now have your x and y coordinates. I do want to point out, why is it that the cosine goes along with x? Well, remember that cosine on the unit circle always represented the x coordinate, right? And didn't sine always represent the y coordinate? And that's why the y coordinate formula is r times sine of theta, and the x coordinate is equal to r times cosine of theta. Now, I do want to mention something to you, or as sort of an example. Remember that the unit circle itself, right? If we take a unit circle, okay, let's go here, and for example, let's take this point over here at pi over 6, right? Pi over 6. Don't we already know that the x and y coordinates at that point are square root of 3 over 2, comma 1/2, right? Well, we can actually use this unit circle and this formula to show that they are related to each other. On the unit circle, what is the radius of the unit circle? Isn't the radius of the unit circle 1, right? It's called the unit circle, right? Unitary for 1, right? And so this point right here on the unit circle has an elevation of pi over 6. So if we draw a terminal side over to here, we know that this angle is pi over 6, because the distance from here up to here is pi over 6. That's a pi over 6 arc. It represents an angle measure of pi over 6, right? And so this point right here, we can identify the coordinates of that point, which we already know. It's square root of 3 over 2 and 1/2, by plugging in the radius. Okay, so the x coordinate is 1 times cosine of pi over 6, right? Well, we know that cosine of pi over 6 off the unit circle is square root of 3 over 2, and square root of 3 over 2 times 1 is square root of 3 over 2. There we go, so we got that point. Same thing here for y. Y is going to be equal to, radius is 1 times sine of pi over 6. Well, we know that sine of pi over 6 is 1/2 times 1 is 1/2, and therefore we can get the coordinates. So we can see that the unit circle itself actually is representing a polar plane that then converts into rectangular coordinates, okay? So here's what I want you to do. I want you to write down these two conversion formulas, that x is equal to r times cosine of theta, and y is equal to r times sine of theta. And I'm going to we're going to now do a bunch of examples where we convert from polar coordinates into x and y coordinates, into rectangular coordinates. All right, so now let's do a few examples. So I've gone ahead and moved our formulas over here so that we can use them whenever we need them. And what I've put here is this question. It says, what are the rectangular coordinates of the polar coordinates 4, 5 pi over 6? Okay. All right, so in order to identify the x coordinate, we're going to use this formula over here. It's going to be radius, which is 4 times then cosine of the theta angle, which is 5 pi over 6, okay? And so we know that that's going to be equal to 4 times, and we know that cosine of 5 pi over 6, well, that's negative square root of 3 over 2, right? Because it's near pi. It's over in the second quadrant. So we got negative square root of 3 over 2. And so now we can multiply these two, and you'll see that if we do 4 times negative square root of 3 over 2, the 4 and the 2, the 2 can cancel, and the 4 can be reduced to a 2, right? And so what we ultimately come up with is that x is equal to negative 2 square root of 3. But I'd also like to identify this in a decimal value. So if we're writing it on paper, we can just write in negative 2 square root of 3. But I know that in some of the things that you have to do online for this class, you have to enter them as decimal values, okay? And so all we have to do is key in negative 2 times the square root of 3, and that gives us negative 3.4641. Negative 3.4641. So that is the x-coordinate. Now we're going to do the y-coordinate. And y is going to be equal to the radius, which is 4, times sine of 5 pi over 6. Sine of 5 pi over 6. Well, this is an easy one. So it's going to be 4 times sine of 5 pi over 6 is 1/2. Well, that's easy. So we're going to multiply by 1/2. And we know that 1/2 times 4 is just 2. And therefore, the y-coordinate is 2. And therefore, the rectangular coordinates of the polar coordinates 4 and 5 pi over 6 are negative 3.4641, comma 2. Okay? And those are the rectangular coordinate conversion of this. Now, what I'd like to do now is I'd like to actually graph this, or see what it looks like on the graph, sort of confirm graphically that this is the case. So we're going to go ahead and pull up the graphs that we have, or the planes that we have available. There we go. Let's go to the polar coordinate. There it is, because we were using 4 and 5 pi over 6. So here's the angle measure, 5 pi over 6, and a radius of 1, 2, 3, 4. That's this point right here. And so what I'm now going to do is I'm going to switch over to the rectangular coordinate and see if it winds up around negative 3.46 and positive 2. All right. And here we are, negative 1, negative 2, negative 3, about negative 3, almost negative 3.5, and there's a positive 2. This is probably just a little off because of my, my scaling, but sure enough, you can see that negative 3.46 and positive 2 is the same thing as radius of 4 and 5 pi over 6, okay? Let's do a couple more examples. All right, so let's look at this one. It says, what are the rectangular coordinates of the polar coordinates 12, 4? Now, you may look at this and say, hey, those aren't polar coordinates. Yes, they are. You were just told that these are the polar coordinates 12, 4. You might think to yourself, but I don't see a pi here. Well, that's okay. This 4 doesn't have to, the radians does not have to have pi on it. It just has to fall between 0 and 2 pi, or 0 and 6.28, right? Well, 4 is between 0 and 6.28. It's a little bit larger than pi, because pi is 3.14. So these are polar coordinates. The radius is 12. That's larger than the graph that we were showing, right? Well, that's okay. Radians can go from 0 all the way out to infinity. And in certain weird cases, you can actually have a negative radius. But generally, it's 0 up through infinity, okay? And so these are polar coordinates. And all we have to do is use our formula to convert into rectangular coordinates. So we know that the x is going to be equal to the radius, 12, times cosine of 4. Now you may say, well, I don't know what cosine of 4 is. That's why you have a calculator. So we are going to use a calculator in radian mode. So you need to make sure that your calculator is set to rad or radians, right? And so now we can just key in 12 times cosine of 4, press enter, and here's what we get. We get that x is equal to negative 7.8437. 8437, okay? And now to find our y-coordinate, all we have to do is radius 12 times sine of 4. Make sure we're in radian mode on our calculator. We are. And we do 12 times sine of 4. That's simple. And we get negative 9.0816. Negative 9.0816. And so the rectangular coordinates of the polar coordinates 12, 4, the rectangular coordinates are negative 7.8437 and negative 9.0816. And we can see, if we were now asked at this point, what quadrant is this polar coordinate point in? We can see that it's a negative on the x and a negative on the y. Negative, negative means it's in the third quadrant, okay? Let's just do a couple more examples. Okay, here's another one. Now things are getting pretty crazy. Now the radius is a decimal value, which is just fine. It doesn't have to be whole numbers. And the radian value, in addition to not having pi, is a decimal value. But that's okay. It's between 0 and 2 pi, so it's definitely fair game. Okay? Why don't you go ahead and hit pause and see if you can figure out the rectangular coordinates of those polar coordinates. All right, so to find the x-coordinate, x is equal to radius 2.73 times cosine of the theta angle, which is 5.5 radians. And we just key that into a calculator. So we're going to go, make sure you're in radians. I cleared my calculator, and it starts out in degrees, so I got to make sure I'm in radians. Then I can do 2.73 times cosine of 5.5, and I get x is equal to 1.9347. That's rounded. 9347. Then my y-coordinate is going to be 2.73 times sine of 5.5. Okay, so 2.73 times sine of 5.5, and that gives me a y-coordinate of negative 1.9261. Okay, negative 1.9261. Okay. And so the rectangular coordinates for that point are 1.9347, comma, negative 1.9261. Okay? All right. I'm probably going to give you, let's do a couple more examples. I'm probably going to have you only go to 2 decimal places when you're doing the quizzes. But I just wanted to show you that you could go out to any number of decimal places given your computer, okay? Or given your calculator. So let's just do a couple more examples, but this time we're only going to round to 2 decimal places. All right, now I'm making things worse and worse here. I've thrown pi back in, but our theta angle measure is now pi over 5. Well, that's not one of our normal radian measures off of the unit circle, which means that we're just going to key it in as cosine or sine of pi over 5 in the calculator, and we're going to get a decimal value, okay? So rectangular coordinates, radius is 25, angle measure is pi over 5, so the x-coordinate is going to be given by 25 times cosine of pi over 5, and our y-coordinate is going to be given by 25 times sine of pi over 5, okay? And so, I forgot to give you a chance to pause the video and do it on your own. You can pause it now if you want to before we run the calculation. But let's go ahead and do that now. So we're going to do 25 times cosine of pi over 5, making sure I'm in radian mode here, right? And I get 20.23. X equals 20.23. And then the y-coordinate is going to be 25 times sine of pi over 5, and that is 14.69. And so our rectangular coordinates are 20.23, comma 14.69. Okay? Let's just do one more example. All right, our last example here, if you want to, pause the video, see if you can figure it out on your own. All right, so rectangular coordinates for the polar coordinates, radius of 5.8, theta angle of 25 pi over 17. And so the x-coordinate will be given by 5.8 times cosine of 25 pi over 17, right? And then the y-coordinate will be given by 5.8 times sine of 25 pi over 17, okay? And so x is going to be equal to, we're going to make sure I'm in radian mode, 5.8 times cosine of 25 pi over 17. And that gives me negative 0.54. Okay? And the y coordinate, I'm going to do 5.8 times sine of 25 pi over 17. And that gives me negative 5.78. And so my rectangular coordinates are negative 0.54. Okay, that's just to the left. It's a negative value, so just to the left of the y-axis. And then negative 5.78, which is almost negative 6, almost 6 units down. So this is in the third quadrant. Okay? All right, so that's it for converting from polar coordinates into rectangular coordinates. Now what we're going to do is we're going to convert from rectangular coordinates into polar coordinates, which is a little more complicated, but it still just uses our regular formulas here.